Let us discuss another classification of signals, namely the energy signal and the power signal. So, signals may be classified as an energy signal or a power signal. Suppose we are having XFT, a continuous time signal, or XFN, a discrete time sequence. Then we can check whether if the given signal is an energy signal or a power signal. So first we should understand what is meant by energy signal. A signal is said to be an energy signal if the if the following integral evaluates to a finite quantity. So limit t tending to infinity. T is actually the time period, but the signal can be a periodic or a non aperiodic signal. In the case of an aperiodic signal, the time period is actually infinity, whereas in the case of periodic signal, then we have a finite time period. So if again this is not the only thing that we need to check to find out whether if the signal is an energy signal. So as per definition, a signal is said to be an energy signal if E energy is finite and power of the signal is 0. So if the energy is finite, the power will be 0. Such a signal is said to be an energy signal. So let us see what is a power signal. A signal is said to be a power signal if power is finite and energy is infinite. So the way we evaluate the power is using the following integral, that is power is equal to 1 divided by 2t negative t to positive t x of t, which will have to be squared and dt, and this should be finite for a signal to be a power signal. Now t is the period of the signal. Now the same see this definition is for continuous time signal. So the same the definition can also be extended for discrete time signal. Only thing the instead of using an integral, we are going to use a sum. So in the case of discrete time signal, the power, okay, energy is limit n tending to infinity summation small n goes from negative n to positive capital N x of n magnitude squared. So the power in the case of discrete time case is P is equal to limit n tending to infinity 1 divided by 2n plus 1 summation small n minus n to plus n x of n within the magnitude squared. Okay, so this is one type of classification where the signal can be classified as either a power signal or an energy signal. So let us take a few examples to check whether the given signals are energy signal or power signal. Let us take a few examples. So which of the following, the question is as follows: which of the following signals are energy signals? So we have E of t minus E of t minus 1. So the signal is going to be as follows. So this is going to be this is what the signal is. Okay. So all that I need to do is I have to use the formula, that is limit t tending to infinity minus t to plus t, and then I have to do the take magnitude and square it, and then so if I want to evaluate this, so it will be limit t tending to infinity 0 to 1, because the time actually starts from before time t is equal to 0, that is for t less than 0, the amplitude is 0. Only between a t is equal to 0 and t is equal to 1, we are having an amplitude of 1, which will have to be squared, and then we will have to integrate it. If I try to integrate it, the answer is going to be 1. So it is a finite. So this signal is an energy signal. Okay, so the given signal is an energy. So since the energy is finite, the power is going to be 0, because we are going to have 1 by 2 times t. So a finite quantity divided by an infinite quantity is 0. So the power is in this case. So this is definitely an energy. So next, we'll take the next example. It says R of t minus R of t minus 2. So let us try to sketch this first. So we have R of t like this. So up to 2, and this is going to be 2 here, and then negative of, after that we have this term, and because of that the signal is going to flatten out. Okay, if it had been 2t, then it would have been like this, but it was not like that. So it is only negative, the slope is only 1 here. So you're going to have a signal, this is going to be the signal for R of t minus R t minus 2. Now if I want to integrate this, suppose let me check whether if it is an energy signal first. So as per our definition, the formula is so minus t to plus t x of t the whole squared dt. So this I can write it as limit t tending to infinity 0 to 2. I'm having t squared dt plus 2 to t, and this is going to be 2 the whole square dt. Now if I do the integration, this term anyway will result in a finite quantity, but this term, if you try to evaluate this, it will be something like this: 4 into t minus 2. And when you try to tend the limit t tending to infinity, this becomes infinite. So the energy here is infinite, so it cannot be an energy signal. Let us try to find out whether, if it is a power signal at least. See, the definition of a power signal is, if the power is finite and the energy is infinite, then such a signal is known as a power signal. So we will just try to find out whether if the given signal is a power signal. So the given signal is, so the definition for a power signal is 1 by t, sorry, limit t tending to infinity 1 by 2t, then we have the integral minus t to plus t, then you have sorry, then you have x squared, x of t the whole square dt. Now let us try to substitute. So limit t tending to infinity 1 by t 1 by, so you have 0 to 2, you have t squared plus 2 to t 2 squared dt. So if you, let us try to evaluate this. So when you try to evaluate this, you get t by 3 by 3 plus 4 times t minus 2. Now this will result in a finite quantity. There is not, this will result in a finite quantity divided by 2t, and here you will have 4t divided by 2t into 2 by 2t. Now when you tend the limit, when you try to substitute the limit, this will become 0 and this will also become 0, whereas this will become 2. So the power here is 2 and the energy is infinity, and as per definition, when the power is finite and energy is infinite, such a signal is known as a power signal. Okay.